Hello students. So welcome to this physics session of this Bohdi Park NEET and J Academy. So download the app from this Google Play. The link is given in the description. So let's continue with our discussion on work for energy MCQs. Look at this question. In this question it is given that the spring of a spring constant 5 into 10 power 3 Newton per meter is stretched initially by 5 centimeter from the unstretched position. So initially the elongation is 5 centimeter. Then work required to stretch it further by 5 centimeter. So what is the new elongation? The new elongation will be 10 centimeter. So initial elongation x1 is equal to 5 centimeter and final elongation is 10 centimeter. So we have formula for external work done. External work done means to stretch a spring, how much is the work done? Suppose this is the spring and you are holding the free end, this is the free end and this is the fixed end. Now free end you are holding it and you are moving it right side to stretch the spring. So the external work done is positive because the external force is right side, external force right side, and displacement is also right side. So the work done by external force will be positive. So we will use the formula external work done is equal to k by 2 x2 square minus x1 square. If the work done by spring is asked, then we will use the formula work done by spring is equal to minus k by 2 into final elongation square minus initial elongation square. So here they are asking what is the external work done. So we will use these values. So we have 5000 by 2 into x2 square, which is final elongation. So convert this in meter. So 0.1 meter. Initial elongation 0.05 meter. So 0.1 square minus 0.05 square. So that is equal to 5 by 2. Now 0.1 square 0.01. So 0.01 into 1000. So that will be equal to 1000 into 0.01, then minus 1000 into 0.0025. So that is equal to 5 by 2 into 10 minus 2.5. So 5 into 7.5 by 2. So that is 5 into 3.75. 5 into 3.75. So it is more than 15. So 18.75, that is our answer, 18.75. Okay. So next question. Now in this next question, particle of mass 10 gram moves along the circle of radius 6.4 centimeter with a constant tangential acceleration. Tangential acceleration is constant, so we can use this formula. V is equal to u plus at. This is the final speed, this is the initial speed in a circle, and v square minus u square is equal to 2as. So constant tangential acceleration. What is the magnitude of this acceleration? Means tangential acceleration we have to find. Kinetic energy equal to 8 into 10 power minus 4 by the end of second revolution. So second revolution. So one revolution, the distance covered is 2 pi r. So second revolution, for second revolution, distance will be equal to 4 pi r. Okay, 2 into 2 pi r. So let's use this formula. So v square minus u square. Now initial velocity is not mentioned, so let's assume it to be 0 is equal to 2as, which is 4 pi r. R is given 6.4 centimeter. So 6.4 into 10 power minus 2. So this is v square, and kinetic energy is given. So half mv square is given 8 into 10 raised to minus 4. So the value of v square 16 into 10 power minus 4 by m. So 16 into 10 power minus 4 by m. M is given 10 grams. So 10 into 10 power minus 3. So this is 16 into 10 power minus 2 or 0.16. Value of v square is 0.16. So substitute here. So 0.16 is equal to 8 pi into 6.4 into 10 power minus 2 into a. So we have to solve this for value of a. So a is equal to 0.16 divided by 8 pi into 6.4, and then this will become 100 over here. So 16 by 8 pi into 6.4. So that is 16, and this is 0.4 times. So 10 by 32 pi. So this will be approximately, we can find the answer 10 by 32 pi. So 10 by pi, 10 can be written as approximately pi square. So pi by 32. So 3.14 divided by 32. So this is a, if we see this, if you multiply and divide by 10, so 31.4 by 32. So less than 1, then divided by 10 also. So less than 0.1. So approximately it is 0.1. Now next question. Question 3. A body is moved along a straight line by a machine delivering a constant power. The distance moved by a body in time t is proportional to. So whenever we have been given instantaneous power, so instantaneous power is given by P is equal to instantaneous power is equal to force into velocity into cos theta. So the displacement and force both have same direction. So theta is 0. So we have P is equal to Fv. Now we have to find distance and time ratio. So we have to find xt relation. So first we will replace F with ma. So mav, P is equal to mav. So we have P is equal to m dv by dt into v. So v dv is equal to some constant dt. If we integrate on both sides, we just have to find the proportionality. So we can see only the powers. So here v power 1. So if you integrate, we get v square by 2, and that will be proportional to integration of dt is t. So we have v is proportional to square root of t. So dx by dt is proportional to square root of t. So dx is proportional to root t dt. Now again you integrate. So we will get x is proportional to root t dt. So that will be equal to t power 3 by 2. Proportionality we are seeing, okay, not equality. So t power 3 by 2. So B option. Now next question. In this question, fourth question, a ball is thrown vertically downward from height 20 meter. So suppose we have, this is 20 meter height, ball is dropped from here with initial vertical with initial velocity v naught. It collides with the ground and loses 50% of its energy, means kinetic energy is lost 50% and rebound to the same height. So it is initially it is thrown with velocity v naught. So suppose this is the ball, it is thrown with v naught. So with what speed it will now it is saying it is rebounding to the same height. Okay, so suppose it is hitting the ground with v1 and it is rebounding with v2. So then it is going up to the same height and its velocity will become 0. So during downward motion, initial velocity is v naught, not 0, it is v naught. Then it is hitting with v1 downward, rebounding with v2, and the topmost point velocity is 0. So vertical displacement same. First displacement downward, second displacement positive, upward. So now we have to find the initial velocity v naught. So how we can solve this question in less steps? So we can check the loss in kinetic energy, which is 50%. during collision. Okay, so what is the initial potential energy? 20 mgh. Okay, initial potential energy is mg into 20. Then it is hitting the ground with kinetic energy, suppose k. Then it is rebounding with kinetic energy k by 2, because half of its kinetic energy is lost. Now conserve the uh, mechanical energy. So here mgh plus kinetic energy half m v naught square. This is the total mechanical energy here. So here also total mechanical energy k plus 0. Now total mechanical energy here k by 2 plus 0. Here total mechanical energy 0 plus mgh. So we will equate k by 2 plus 0 is equal to 0 plus mgh, and we find this k value from this. So if you consider here to here, so mgh plus half m v naught square is equal to 0 plus k. So k value we will put from here. K value is mgh plus half m v naught square. Mgh plus half m v naught square by 2 is equal to mgh. So half m v naught square plus mgh is equal to 2 mgh, or half m v naught square is equal to mgh. M cancel, so v naught square is equal to square root, okay, v naught will be equal to square root of gh, and h is given 20 meter. So square root of 20 into 10, that will be equal to 10 root 2, so 10 into 1.4, so 14 meter per second, D option. So using energy conservation. Now next question. In this question, particle of mass is driven by machine that deliver constant power. Again, this question is based on power, so we have power is equal to F into V. Power is constant. If particle starts from rest, the force on the particle at time t. So we have to find force. So F is equal to ma. Now first we will find V in terms of t. So P is equal to, now constant power is given K, so we will consider P is equal to MAV. So K is equal to A is dV by dt into V. So V dV is equal to K dt by M. So K by M into T is equal to V square by 2. Okay, limits will put 0 to V and here 0 to T. So KT by M is equal to V square by 2. Now find V, and V square is equal to 2KT by M. So V is equal to square root of 2KT by M. This is V. Now find acceleration using dV by dt formula. Acceleration is dV by dt. So this is square root of 2k by M, then square root of t. Root t differentiation is 1 by 2 root t. So this will become square root of k by this root 2 by 2, so 1 by root 2, and root t into root t. So this will become t square here. So basically this is k by square root of k by 2 into 1 by t. So this is acceleration. So force is equal to m square root of k by 2 into 1 by t. Okay, so question number 5. So P is equal to ma into V. So K is equal to m dV by dt into V. So V square by 2 is equal to KT by M. So V square is equal to 2KT by M. Now V is equal to square root 2K by M into root T. So acceleration is equal to dV by dt. So dv by dt, differentiate this square root of 2k by m. Now square root of t, it will be 1 by 2 root t. Now f is equal to ma. So we have m square root of 2k by m into 1 by 2 root t. So this m by root m means root m. Then this is root 2k by 2. Then 1 by root t. So root 2 by 2, 1 by root 2. So root m by root 2, root k by root t. So square root of mk by 2 into t power minus 1 by 2. So this is our answer, D option. Now next question. Question 6. A sphere of mass 8m collides elastically with a block of mass 2m. Let's draw the diagram. So suppose this is the sphere, the mass is 8m and this is the block. The mass of the block is 2m. Elastically means the kinetic energy is also conserved, momentum is also conserved. If initial energy of sphere is E, so suppose this velocity is U and this block is at rest, it is not mentioned what is the initial velocity of block, so you assume it to be rest. This is before collision, and after collision the velocities of these ball and block v1 and v2. So now in the question it is given initial energy is E, so basically U is given, so half 8m into U square is E. Now let us find v1 and v2 using formula of momentum conservation and coefficient of restitution, and then we can find the final energy of sphere. So basically final energy of sphere is half 8m into v1 square. We have to find v1. So using momentum conservation, that is linear momentum conservation. So after and before, so 8m into u plus 2m into 0 is equal to 8m into v1 plus 2m into v2. So we have 8mu is equal to 8m v1 plus 2m v2. So 8u is equal to 8v1 plus 2v2, or 4u is equal to 4v1 plus v2. Okay, this is first equation. Now coefficient of restitution formula is v2 minus v1 by u1 minus u2. So perfectly elastic collision means E value is 1. Then v2 minus v1 by u1 minus u2, so that is u minus 0. So v2 minus v1 is u. We have to find v1, so eliminate v2. So 4v1 plus v2 is 4u. Now use these two equations. So we get, if you subtract this minus second minus 1, second equation minus first equation. So 4v1 plus v1 is equal to 3u, or 5v1 is equal to 3u. So v1 is 3u by 5. v1 is 3u by 5. Now put it here. So 4m into 9 by 25 u square, and 4mu square is E. So we have 4mu square is E. So this will be 9e by 25. Now 9e by 25. So that is equal to 0.36 E. So B option. Next question. Seventh question. Okay, look at this seventh question. Two similar springs P and Q have spring constant Kp and Kq such that Kp is greater than Kq. They are stretched by the same amount, means elongation is A. Then by the same force. There are two cases. So in case 1, elongation is same, and case 2 force is same. Work done by spring. So work done formula we can use. When elongation is same, we can use the formula half k x square, and when force is same, we can use the formula uh, half k x square. Now multiply and divide by k. This will become half k square x square by k. So f square by 2k. So for when force is same, use this formula f square by 2k, and when elongation is same, use this formula. So in case 1, we can say WP by WQ is equal to KP by KQ. Now KP is greater, so WP is greater for case 1, and for case 2, W is inversely proportional to K, so WP by WQ is equal to KQ by KP. Okay, so WQ will be greater, so B option. Next question. So look at this question. In the figure, the variation of potential energy of a particle of mass 2 kg represented with x coordinate. Basically, ux graph is given. Particle moves under effect of conservative force along x-axis. So ux graph is given. This is the graph. Now let's solve the question now. If the particle is released at origin, so we have to answer these questions whether it is true or false. Okay. So released at origin means x equal to 0. So basically the formula for force is equal to minus du by dx. Du by dx at x equal to 0. Du by dx is positive. If you see here the tangent, if you draw tangent here, it is making less than 90 degree with positive x direction. So slope is positive. So force will be negative because minus du by dx. Force is negative. So if it is released at origin, so force is negative. So the particle will move left side. So B is correct. B is correct. Clear? Okay. Next question. Force applied by engine of a train is 2.05 into 10 power 6 kg and changes its velocity from 5 to 25 in 5 minutes. What is the power? So that is average power, and formula for average power, total work done by time taken. Total work by total time taken. Now total work done is equal to change in kinetic energy. So that is equal to half m v2 square minus v1 square divided by time taken. So just substitute the values. So we'll get the answer. So half into 2.05 into 10 power 6. Then v2 square 25 square minus 5 square. So 625 minus 25. Then divided by time taken, which is 5 minutes, convert into seconds. So 5 into 60. Now let's do it. So 2.05 by 2 into 10 power 6, and this is 600, and this is 5 into 60. So 60 cancel, 10 by 5 is 2, so this all cancel. So 2.05 into 10 power 6 watt, or 2.05 megawatt. 10 power 6 watt means megawatt. 2.05. Clear? Okay. Now next question. So let's read the question first, because we have to check the options also. Block C of mass m is moving with velocity v0, collide elastically with block A of mass m. Means both are identical mass. C and A both have same mass. C of mass m, A of mass m. So when elastic collision is there, the velocity gets changed, interchanged. Clear? So just after collision with A, the velocity of C becomes 0 and velocity of A becomes v0. Okay. So the concept is, for identical mass collision, for identical masses, elastic collision velocities interchanged. both bodies will exchange their velocities. So before collision, C is moving with V naught, A is at rest. So after collision, elastic collision, C will come to rest, A will move with V naught. So the situation will be like this. A is going with V naught and spring is unstressed, spring is relaxed, and B is at rest. But what happens? The A will move right side. A has got momentum, so the spring will get compressed. So when spring is compressed, it will push B also in the right direction. X naught is the compression when velocity of A and B is same. So after some time, both will have same velocity. And block B of 2m. So this is 2m and this m. Both have same velocity v. So let's conserve the momentum first. So initial momentum mv naught plus 0 and final momentum mv plus 2mv. So mv naught is equal to 3mv. So v is equal to v naught by 3. We got velocities of both the blocks, v naught by 3. Now find out the kinetic energy, and we will use energy conservation. So initial kinetic energy plus potential energy is equal to final kinetic energy plus potential energy. K initial plus U initial is equal to K final plus U final for system, for these two blocks. So we have half mv naught square plus, now initially the spring is relaxed, so potential energy is 0, and K final half mv square plus half 2m v square, so half 3m v square, and v is v naught by 3, so v naught square by 9, and u final is half k x square. So half m v naught square minus 1 by 6 m v naught square is equal to half k x square. So 2 by 6 m v naught square is equal to half k x square. Then 2 by 3, so I'm doing here 1 by 3 m v naught square is equal to kx square by 2. So 2 by 3 m v naught square is equal to kx square, or x square is 2 by 3 m v naught square by k. So x is equal to square root of 2 by 3 m by k into v naught. So we have to find k. Okay, we have to find k value. Okay, k value is equal to 2 m v naught square by 3x square. So that is D option. So here we finish this question. Okay, thank you so much.